Dr. Wiseman enjoys giving talks to churches, schools, and civic groups on the excitement and inspiration of astronomy and scientific discovery, and she has also appeared in many public science and media venues. So, Dr. Wiseman.
Thank you. Thank you so much. Thank you very much. I learned that Wendy is a veterinarian, and I grew up loving animals myself. And people, when I was growing up, said, "Oh, you like animals? You should maybe see if you can become a veterinarian." But I didn't really like the plumbing of the animals, you know. It's like I like having relationships with animals, but I really appreciate people like Wendy who can fix them, you know. So anyway, it's a pleasure to be here. I'm honored to give the Kent Memorial Lecture and for Wesley Nexus, and you're going to have to bear with me because I'm used to having a clicker, but we don't have that tonight, so I'm going to have to say next slide, but hopefully you'll learn to just kind of filter that out after a while. We've all either driven here through traffic, or if you're watching online, you've had to figure out how to navigate getting time to watch this. You're all welcome. We've all got a lot on our minds. We've all got a lot of things we're concerned about. So why don't we take just a moment to everybody take a deep breath and breathe out. And we're going to try to think about the bigger picture this evening for a little while together. And I mean a big picture because Maynard Moore, who worked so hard to set up this evening, but he invited me to speak, and of course I'm an astrophysicist. I like to talk about the universe. And he said, well, that's okay, but can you also talk about planet Earth? People are going to want to know, you know, how this relates to planet Earth. And I said, well, I'm not an Earth scientist, but I can try to bring a little bit of that in. And then he said, oh yeah, and you know, this is a group that wants to know about the relevance to faith. So can you also talk about the future of faith? And so, you know, this is kind of the definition of an unfocused talk, right? So we got the universe, and then the earth, and then the future of faith, and it's all got to fit here within an hour. So let's just go with it and see how this comes out. Anyway, I welcome you all here tonight, and I welcome those of you watching online as well. I have many friends here, including many from my husband and I belong to National Presbyterian Church in Washington, D.C., and so I welcome those of you from our church. And we belonged to a little country United Methodist Church for well over 20 years up in central Maryland. And so my heart is still connected to the United Methodist tradition as well. Okay, next slide, please. And can we, in the room here, can we darken the lights a little bit? Yeah. All right, so it's an end of a long week. You might be tempted to fall asleep. That's okay. But I just want you to get a glimpse of stars, and I like to start my talks with this slide because it is basically a bunch of stars, but you don't see them like this when you go out at night. And there's a couple of reasons. One is that we have polluted our night skies with so much city light that people really can't. And that's too bad. We've really robbed ourselves of a nightly engagement with the universe. But you'd never see this, even in a really dark place, because this. If those of you who have your own telescopes, you may have looked up and seen globular clusters. But this is one that's been highly resolved, so you can pick out the individual stars. It's the newest camera on the Hubble Space Telescope, and this was just a calibration image, and it shows you not only what you can do with a great telescope that's up above the clouds, so you can, but it also shows you the beauty of individual stars because you separate even from this picture that stars are not all the same, right? They're different, and I'm going to ask to just yell out some things you notice about these stars. Don't be shy. Ah, I hear different colors. What colors do you see? Yep, that's good. Which ones do you think are the hottest ones? That's a little test of your science knowledge. They're all hot, right? They're all stars, but the blue ones tend to have the hotter outer layer than the red ones. And if our sun were in such a crowded neighborhood, we'd be like one of the little tiny whitish, greenish dots in there. Our sun is not in such a crowded neighborhood. But you can see here already that stars are beautiful and they differ from one another. And of course, by separating this way, we can also study them scientifically. So astronomers can take individual stars in a cluster like this and take a spectrum of them, like taking the light and spreading it out into its constituent colors. And that tells you something about the composition and the age and so forth. So you can learn something about the formation and the history of these stars. But we also see that there's beauty and variety amongst them. And we're able to see that because we have a good telescope. And those of you who want extra credit tonight, you will find somewhere in the New Testament a verse that says star differs from star in splendor. And so if you find that out, you get extra credit where that is. Okay, next slide, please. I want to just mention, because this weekend is called Faith and Science Weekend, and science and technology are not just, classes that you may have liked or avoided back in high school and college. They're actually intertwined with everything about modern life today, right? So science and technology affect everything from our food and agriculture to communications to, of course, computers and now artificial intelligence. To the way we think about ourselves, to education, space exploration. You can maybe tease out the list there. And these are just some of them that I thought of when I was making the list. And of course, intertwined in all of these applications and uses of science and technology are social justice issues and societal issues that kind of shape how we have developed these techniques and how they're used for better or worse. So tonight we're focusing on, as I mentioned, astronomy and a little earth science, but I wanted to mention that this is in a bigger context of how science and technology relate to the world today. Next slide. And so I want to give a little advertisement here for a program that's part of a science society. The largest international science society is called the American Association for the Advancement of Science, or the AAAS. AAAS publishes a journal called Science, and also has several public engagement programs regarding science. And one of them is called the Dialogue on Science, Ethics, and Religion, or DOSER program. And this is a program within a science society to help facilitate conversations and dialogue between scientists and faith communities and ethicists, and these are overlapping groups, right, about how we can use science and technology to best benefit society and the world at large. So I encourage you to look up this program and its resources, and you'll hear a little bit more from its director. The current director of DOSER is Dr. Katy Hinman. She's right here with us tonight. And she'll be leading, she'll be our respondent and leading some of the conversation after my talk. Okay, next slide, please. I love the idea of beauty in space. What drew me into astronomy was looking up at the night sky. Now, I never saw anything quite like this because you need a good telescope. But the universe is active. This is an example of what I call beauty in the heavens. It's a cluster of stars, poetically named NGC 3603, that have recently coalesced out of a lot of this interstellar gas. So up in our galaxy there are many stars and there's lots of gas, wispy and turbulent, but sometimes the clouds of gas get denser, and if there are pockets that are dense enough, they'll collapse under their own gravitational pull into dense cores of gas that become stars. And they become stars when the gravitational pressure becomes so large that the hydrogen atoms begin to fuse into helium atoms and other heavier elements, and this process releases photons of light. That's basically what a star is doing. It's creating heavier elements and light. And then the winds and radiation from those newly formed stars go back out into the surrounding leftover gas, start shaping it, blowing it away, and ionizing the gas, which creates the beautiful colors. So when we see a colorful nebula like this, we say, wow, that's beautiful. But we also say, wow, star formation must have been relatively recent. By recent, I mean, you know, in the last few 100,000 years. So that it is creating this juxtaposition of leftover gas and stars and beauty. But I didn't grow up knowing anything about professional science. Next slide, please. I grew up here. So this is our family farm in the Ozarks of north central Arkansas. We had a beef cattle ranch, and I still go back there as often as I can and wander around, because every day is different. And so I love just observing nature throughout the seasons. Every day is different. You see different flora and fauna, wildlife, and flowers, and I loved wandering, looking at streams and meadows, and I love animals, whether they're livestock or wildlife or pets. And I think it's this observation of nature that made me interested in science, because science is the systematic study of the natural world. And I'm fortunate that I was able to make that connection. I also love the night sky. We would go out walking every evening, my parents and I, and just kind of look up. And those were the years when some of these big popular science fiction movies were starting to come out, you know, Star Wars and all of that. And so we were all thinking about space. And then the Voyager probes were sending back these images from the outer planets in our solar system. And I was absolutely fascinated watching Cosmos every week on television and wondering how could I get involved in this enterprise of studying space. And I didn't know how. My parents didn't have a chance to go to college, but they made sure that their kids did. And I got encouragement from my local teachers in the public school, local guidance counselors, my family. My older brother was the first pioneer to go off into education, and he encouraged into higher education, and he encouraged me to do the same. And my church, which was a loving church. We didn't know anything about formal science, but we knew that God's creation was good. And I think I got this encouragement in that environment that studying anything about the natural world could be done in such a way that God would be glorified. So I'm thankful for what I grew up with. Next slide. So I think the overall message that I hope you already are gleaning is that we live in a universe that inspires curiosity, wonder, and awe. Next slide, please. I hope you already feel that, whether you are a biologist looking at life or someone who looks at the tiniest subatomic particles. I'm thinking of Bill Phillips right here. Or if you basically are not a scientist by training or by occupation, but you love looking around the natural world. I hope you glean and continue that sense of wonder and awe. Next slide. Let's take a moment to just window shop at some of the beauty of the universe. So here is a galaxy. Galaxies contain hundreds of billions of stars. So many of those clusters, like I showed earlier. And spiral galaxies like this can have these, fantastic windmill-like arms that are filled with these hot spots. The little purple spots all along the arms are all these nebulae, like I showed you before, where stars are rapidly forming and brightening up the surrounding leftover gas. So spiral galaxies can be like little star formation factories. And you also see dust along those spiral arms. And in the middle of spiral galaxies, you see a glow because there's so many stars that have migrated toward the center that the light just kind of blends together. And if you observe with the right kind of telescopes, you'll see evidence in the middle of most galaxies for something called a supermassive black hole. kind of by definition, you can't see a black hole, but you can see stuff orbiting around it and falling into it, and you know by the velocities of orbits that there's something really massive and compact in the middle of galaxies, including our own Milky Way. Next slide. How do we know all this stuff? Well, we use the tools of telescopes. So I just show some examples here. We have telescopes in space and on the ground. And we need them because each type of observatory gives you a different type of information. So we have telescopes in space. The one you see on the top there is the Hubble Space Telescope, which has been orbiting the Earth for 35 years, but it's been upgraded several times by astronauts. There are other telescopes in space that are doing wonderful types of observations. We have telescopes on the ground, like the Keck telescopes on the lower left there in Hawaii, and the ALMA array of radio telescopes seeing sub-millimeter wavelengths of light and millimeter wavelengths of light, and they're based in South America. All these types of observatories are like, I think of them as like different types of instruments in an orchestra, and they each give you a different type of information. Either they see a different color of light or a different swath of the sky. But together, an astronomer can take information from these different facilities and piece it together like a symphony conductor brings music in from different instruments to give you the full concert or the full information about whatever you're looking at and studying, whether it's galaxies or stars or planets. Next slide. And, you know, a lot of these facilities require a lot of human ingenuity and interaction. So these are astronauts actively upgrading the Hubble Space Telescope during the last space shuttle visit to the telescope back in 2009. They did such a great job that the observatory is still in excellent condition, and I'm thankful for that. Next slide. And now we have another very large space telescope called the Webb Space Telescope. It sees a different color range of light than Hubble does, so these two are very complementary. Webb is extremely powerful, and it's designed to see infrared light, so it has to be kept very cold, and that's why those kind of tennis court-like sun shields are underneath the sensitive instruments on the telescope. Next slide. And so we're starting to see things with Webb that we weren't quite able to see in quite that way before. So here's the edge of one of those star-forming regions. And if you look carefully in the red cloud, you can see a lot of these pillar-like structures that are being carved out from the winds and radiation from young stars that have recently formed that are up above in the blue area and off the top. So this is the interface region of a recently formed cluster of stars and the edge of the cloud, the leftover gas out of which those stars form. Next slide. When we look at anything with different colors of light, we get different information. So here's our friend Jupiter with Hubble, which sees visible light and some ultraviolet light on the left, and the Webb telescope seeing infrared light on the right. And you can just see visually that you're picking up different kinds of information. And you know, Webb is picking up for us some of the hazes and things around the outer atmosphere. Hubble has shown us for years that the weather on Jupiter is changing, and that big great red spot is shrinking. It's a big hurricane. It's speeding up. Other little storms are cropping up. So again, we use this information in complement to give us more information than any telescope could on its own. Next slide. For planets that are close to us, we can also actually send rovers to go and probe. So this is Perseverance on Mars, driving around, taking pictures and samples and giving us information about this planet. Next slide. And of course, we're learning a lot about Mars. We're hoping to send people there before too long, but Mars is cold and it's barren. It seems like a desert, but if you dig a little bit under the dirt, you see that there's a whole layer of water frost, and there are signs that there were rivers and lakes and all kinds of liquid water on the surface of Mars in the past. The climate was different. So what happened that made a habitable planet turn into a cold desert over long periods of time? It's something we want to learn. Next slide. We're learning that the universe is beautiful. I hope you've already seen some of that. It's active. A lot of people think, yeah, I'm kind of aware there's space out there, planets and stuff. But it's not just stagnant. There's stuff going on. It's enormous in terms of the size span and the content and the length of time that we're talking about for the history of the universe. And it's progressing, and what I mean by that is that the universe over cosmic time seems to have changed and become more habitable toward the formation of planets and the sustaining of life. So we'll talk about that. Next slide. Back to our star cluster. So this is called Omega Centauri, but it's very hard to understand the context of this by just looking at the tiny field of view that Hubble has picked out here in great detail. So we're going to look at this region with a different telescope now that sees a much wider swath of the sky. So telescopes like Hubble and Webb see a tiny field of view, like holding a grain of sand out at the end of your arm, and that's the kind of field of view that Hubble and Webb telescopes can see, but they see great detail like you see here. But if you have a different kind of telescope that sees a wider swath of the sky, it helps you understand the context. So let's go to the next slide here. This is a different telescope on the ground that's looking toward the center of our Milky Way. So you see a lot of dust and gas and a lot of things that look like stars. And we're going to zoom in now on one of those star-like spots and then transition over to an image from a different telescope that sees a little more detail, and then eventually to the Hubble's view. So if you can click that go button on this animation, there we go. It's the Centaurus constellation. We're zooming in on one of those things that looked like a star. But now we transition and see that it's actually a globular cluster of stars. And then we transition into the Hubble image that shows us the individual stars. So do you see why context matters, right? You kind of need the big picture to know what you're looking at, and then you need the detailed picture to see what's inside. And so and that's true for a lot of things in our world, but it's certainly true in astronomy. So let's go to the next slide. Keep going, next slide, yep. Here's another one. So this is a telescope from the ground looking at a region that I hope you recognize. Anybody in here recognize this region? That's right, this is Orion. So it's a big field of view. So you see a lot of the stars, and those of you who know your astronomy and constellations, you might recognize the belt in the middle and Orion's sword, and up at the upper part you see a red star, red giant called Betelgeuse, and lower right you see a big blue star called Rigel. But in the middle, those kind of stars that cluster in the middle, they're all kind of fuzzy. We call them nebulous just because they're kind of fuzzy. And that usually means there's a cloud or nebulous material around the stars. Next slide. So we're going to look in more detail in one of these with the Hubble telescope. So Hubble doesn't see this wide swath of the sky, but it sees a lot of detail right where that arrow is pointing. Next slide, please. And when we do that, we see this. So this is the Orion Nebula. And again, it's one of these regions where massive stars have recently formed, and they are lighting up the surrounding gas, ionizing it. For my own PhD research, I looked at this region with a radio telescope and was able to look through this bright light to the dark cloud behind it where protostars, baby stars, are still forming. If you look carefully in this region, though, you see other things happening. Next slide, please. Here's a couple of blow-ups of two little dots you might have missed. These are baby stars still trying to coalesce and form and accrete material. We call them protostars or young stellar objects. And these two have these dark, dusty disks around them. So you can see one kind of face on and one kind of edge on. These disks are about the diameter of our solar system. So we now know that as stars form in our epoch of cosmic time, they form with these dusty disks around them where planets form along with the star. And now the study of these disks and planet formation is a hot topic in astronomy and astrophysics. And of course, we now know that there are planets around that have formed around other stars. We didn't know that for sure when I was in graduate school, but now we've detected thousands of these planets called exoplanets in our own neighborhood of the galaxy, and it now looks like most stars have at least one planet. Next slide, please. So this is an example of, it's an artist's conception, but of a real system that has been discovered of a star with 6 planets in tight orbits around that star. And so now astronomers are in a hot game of trying to understand the nature of these planets that orbit other stars and how they relate to planets in our own solar system. Next slide. Stars, as they form, also impact their surrounding environment. So this is a super jet being ejected from one of these forming stars in another part of the galaxy, so on the outskirts of the Milky Way. This was recently imaged by the Webb Space Telescope, and it's fantastic. So you have material that's falling into the star as gravity pulls it in, but some of it gets caught up in magnetic fields and kind of ejected out the poles of the young forming star. And these jets can be very powerful. This one is twice, the length from tip to tip is twice the distance of our sun to our nearest star. So it's huge, and it's impacting the surrounding environment, and it's all a part of the turbulent adolescence of stars as they form. Next slide, please. Old stars also impact the surrounding environment, so they tend to shed their outer layers when they start getting unstable. Stars run by fusion, as I talked about, but then they start running out of hydrogen atoms in the core, they become unstable, and some of the stages include ejecting some of the outer layers of the star. Well, that means that it's ejecting some of the material that was forged in the star during all these years of fusion going on in the core. So you have heavier elements that were created inside the star being ejected out, including things like oxygen and carbon and nitrogen. Next slide, please. And big stars, bigger than our sun, get so unstable that they actually explode when they start running out of fuel. We call this a supernova. And this is the remnant of a supernova that happened 1,000 years ago, and we can still see the debris moving out back into those interstellar clouds. And the debris consists of those heavier atoms that were forged inside the star, and also some heavier elements that were created in the explosion itself. And so stars are little factories that create heavier elements and then disperse them back into those interstellar gas clouds so that subsequent generations of stars can form enriched by some of this material. And that means they're planetary disks, and the planets that form around them are enriched by this material created by previous generations of stars. We now believe our own solar system, our own sun, is not a first generation star. We're taking advantage of material created by other stars that have come and gone. Next slide, please. So all this material is filling the volume of galaxies. Here's one of my favorites. And there's, as you look in the spiral arms, you see the clouds, you see dust, and most of the matter in this galaxy you don't see because it's called dark matter, but we know it's there because we can see its gravitational effects. We just don't fully understand yet what dark matter actually is. Next slide. And as we look at galaxies, we see their differences. These are a bunch of images taken in ultraviolet light with the Hubble Space Telescope. That's that energetic bluer than blue light that our eyes can't see, but Hubble can pick it up and show us the hot spots where stars are forming in these galaxies. Next slide. Galaxies are active in and of themselves, but they're also active with other galaxies. They often merge with other galaxies if the gravitational pull between them is strong enough to overcome their tendency to move apart from each other with the expansion of space. So here's a couple of galaxies that are in the process of merging. We think our own Milky Way is the product of mergers, and it will be again in the future. So this is an ongoing way that galaxies build up mass. Next slide, please. Here's another pair of galaxies that are farther along in the process, and that merging stirs up the gas and stirs up star formation. So that's sometimes called a starburst. So eventually these two will become a fully merged galaxy. These are called the antennae galaxies. Next slide. The universe is full and active, and it's also very rich and enormous in space and time. So let's talk a little bit about that. Next slide. We love galaxies, but for the last 100 years, we now know there's more than one. Edwin Hubble helped us understand that there are galaxies beyond our own. Our own is the Milky Way. Next slide. We can't get all the way out of the Milky Way to take a selfie, so we have to kind of look around inside, and we believe our galaxy looks something like this. And if you can see on this slide toward the bottom, you'll see a little arrow that says our solar system. That is where we are right now, the sun and the planets we're familiar with orbiting the sun. But we're also orbiting around the galaxy as a whole. Again, galaxies can contain hundreds of billions of stars. And if each one of those stars on average has a planet, which is what it seems like, there's a whole lot of planets in our Milky Way galaxy. Next slide. Well, what do galaxies look like as we start looking at them in mass? Well, we have a brand new observatory on the ground called the Vera Rubin Observatory, named after pioneering astronomer Vera Rubin. And it's in South America. That's a nice picture of it right there with a star cluster behind. And its forte is seeing a wide swath of the sky. You know, not the tiny fields of view that Hubble and Webb see, but the wide swath of the sky and surveying the sky night by night. So let's look at the next slide. So this is one of its beautiful show-off first pictures. Called Cosmic Abundance, and I really love this picture. These are galaxies, you know, and you see all these little swirls and different shapes, and up in the upper right you see some galaxies there that are interacting with each other as their gravity pulls material from one to the other. It's almost like a beautiful dance, like a ballet, and I love this image because it kind of gives you the visceral sense of what we mean when we say there's hundreds of billions of galaxies in our observable universe, each one of them carrying its own beauty. And of course, these galaxies are at different distances. So we're not seeing anything as it is right this minute, right? We're seeing things in astronomy as they were when the light began traveling toward us at the speed of light. And so some of these galaxies are farther than others. The ones that are most distant, we're seeing them as they were farthest back in time. And we can compare them with galaxies closer to us in space and therefore in time, and see if galaxies have changed over time. We can't follow a single galaxy as it changes over billions of years, but we can compare galaxies from different epochs of cosmic history and see if they are different from one another, and indeed they are. Next slide. So here's another way of looking at that. As our telescopes and cameras and detectors have gotten more sensitive over the years, going from top to bottom, it means we're able to see fainter and fainter things in space, and that translates to seeing more and more distant galaxies. So that's what those arrows are showing, that we're getting to see farther and farther out in the universe as our telescopes get better. Well, that's equivalent to looking farther and farther back in time. So that x-axis, the axis on the bottom, goes from right to left, with the beginning of the universe being off the right-hand side and now being on the left side. And so we're now seeing baby galaxies with the Webb telescope from very early on in the universe. So we know that the universe is about 13.8 billion years old, and we're seeing well within the first 0.8 of that 13.8 billion year history of our universe. And we can compare those baby galaxies with galaxies closer to us in space and time and to our own, and see if things have changed. Next slide. And they have. So here's some galaxies pulled out from one of these deep universe images taken with the Hubble telescope, and you can see that the most distant galaxies, which are sampled there on the right squares, are smaller and more ratty looking than the ones closer to us in space and time, like the ones on the left. And that's because galaxies over billions of years have merged with other galaxies, as I showed you. They've gotten bigger. They've had time to develop these complex structures, and they've had generations of stars coming and going to enrich the content of the gas and future stars in these galaxies with the heavier elements created from previous generations of stars. So indeed, galaxies themselves have evolved over cosmic time to create the places that we are familiar with now in galaxies like our own Milky Way. Next slide. And in fact, this process got going early. So this is one of the early montages from the Webb telescope, which can see some of those baby galaxies in the early universe, because Webb is very sensitive, but it's also an infrared telescope. So the light from those galaxies may have started out ultraviolet, but by the time it passes through expanding space, it's shifted into the infrared wavelengths of light that Webb can pick up. And what it's picking up is that these galaxies became bright and active in forming stars pretty early on, within the first few 100 million years of the universe. Galaxies were very actively forming stars. Next slide. So, we've learned that the universe has developed over billions of years of time, and it continues to mature and change with the production of stars within hundreds of billions of galaxies, and those stars creating heavier elements, and planets. And these provide conditions needed for life to thrive on at least one planet. All right? So there's been this progression that we can actually observe with our sensitive telescopes now of the history of the universe since the Big Bang. Next slide. So does that imply there is a purpose for the universe? Since we see this, we see the development. I have just jumped from a scientific story to a philosophical question. Did you see the jump? All right. Not everybody notices when scientists jump from talking about data and to talking about its philosophical implications. So, does the universe have a purpose? Most people, most scientists around the world would agree with the scientific picture that I just described to you from what we've observed and what we've learned from the last century of astronomy. But do you think they all agree on the question, does the universe have a purpose? Let's go to the next slide here. So the Templeton Foundation some years back asked a lot of leading scholars around the world this question. So these are top scientists and historians and theologians and philosophers. Does the universe have a purpose? And they were to give a one-word or one-phrase answer and then a longer one-page essay explaining their answer. And so I don't know if you can see some of these examples of people that were asked, but you might recognize Neil deGrasse Tyson there, or Owen Gingrich, or some of these other famous folks. I'm going to pull out a few, for example. Next slide here. So here's a scientist, Professor Peter Atkins. When asked, does the universe have a purpose, he says, no. In fact, he says, in the absence of evidence, the only reason to suppose that it does is sentimental wishful thinking, which underlies all religion and is an unreliable tool for the discovery of truth of any kind. Got it? Okay. Next slide. Same question. John Haught, professor here at Georgetown University. Does the universe have a purpose? He says yes. The fact that we're even asking this question at all suggests that there might be an affirmative answer. This impassioned search for meaning, which is perhaps our species' most distinctive trait, is not some longing that lifts us out of the universe or that takes us out of nature. I mean, it's part of our very character. If we're thirsty, it must mean there's such a thing as water, right? So he says, so too is our thirst for meaning. Next slide. And then Dr. Jane Goodall, who recently passed away, and we mourn the loss of Jane Goodall. She said, certainly. She said, of course, science typically scoffs at any belief in a God and tells us that we must have just this God gene and that tendency toward religious belief is simply part of our biological makeup. But she said, but even if this were so, we would still need to ask why. Why are we programmed to believe in a God, and why are the laws of physics designed to make life ever more complex? Where did those laws of physics come from? So there's always a why before the physical questions that we can answer with science. Next slide. And so I caution that we should beware of nothing buttery, and I did not invent this phrase, but it means, if you ever hear somebody say we're nothing but our genes, or nothing but our neurons, or nothing but the atoms that make us up, that's called nothing buttery, and it's also called reductionism. And we now know that, we can understand the components of different aspects of our bodies and our life and our history, but nothing of it alone explains everything about our being and everything about our purpose. Next slide. And then there are these deep questions that we have that sometimes go beyond the science. What is the origin of the universe, and what is the ultimate fate of the universe? I mean, we can talk about the origins of the Big Bang or whether there's a multiverse. We can look at those kinds of things from physics, but then there's, again, that question behind all of that. Who set up a multiverse? Why is there that? Or, is the ultimate fate of the universe just to freeze out and go dark? And is that the only reality that we have in our far distant future? And what does that mean for our own existence? And so it starts begging these deeper questions beyond the tools of science alone. Next slide. And these questions need something beyond science alone to address them. And that's why we need philosophy, we need history, we need theology. And in terms of theology, I like here what Sir John Polkinghorne said. He was a physicist who became an Anglican priest later in life, did a lot of wonderful writing about the relationship of science and religion. He said science and theology are both concerned with the search for truth. In consequence, they complement each other rather than contrast each other. Of course, these two disciplines focus on different dimensions of truth, but they share this common conviction that there is such a thing as truth to be sought. And I think that's an interesting observation. People sometimes are surprised when I tell them that when I went to school back at MIT, and I was active in some of these Christian fellowship groups, and this was also true in graduate school at Harvard, most of the other students who were drawn to these kinds of groups were science students, science and engineering students, because there was this common sense that there's truth to be sought, and different kinds of truth require different kinds of tools, but there is such a thing as truth. Next slide. And then we can talk about not only just the abstract ideas of religion and philosophy and science, but we can talk about the people involved. Scientists, people of faith, philosophers, ethicists. These are overlapping groups, of course. And I like what Dr. Nancy Edelman said here. She's a professor here at Catholic U in D.C. She said scientists and people of faith speak a common language, which is awe and wonder about the world at large. So we can meet on this common ground and consider our common interest. I agree. Next slide. All right, some people start wondering, when they see all this, are we insignificant when we think about the magnitude of the universe and the age of the universe and our tiny little planet around one little star? That is a philosophical question. Next slide. We started thinking about it a lot more when we started going into space and looking back at Earth from the Apollo years, and now here's an image from the Cassini spacecraft looking at the dark side of Saturn, and you can see some of Saturn's rings there close up at the top. And then at the bottom right there, you see a tiny little arrow pointing at a tiny, tiny little white dot. That's us, right? That's Earth. That's all the history of Earth and all the, I think Carl Sagan pointed this out. Every war, every book, every part of our history is on that little dot. So how does that make you feel? Next slide. So there are different reactions to this. Next slide. Carl Sagan said that we live on who are we? That we find that we live on an insignificant planet of a humdrum star lost in a galaxy tucked away in some forgotten corner of a universe. Do you ever feel that way? But that's not the only possible reaction to this. Next slide. I like what the psalmist in the Bible said, who was also reflecting on the vastness of space, probably a shepherd looking up at the stars, and said, "O Lord, our sovereign, how majestic is your name in all the earth. First, the insignificance. When I looked at your heavens, the work of your fingers, the moon and stars that you've established, what are human beings that you're mindful of them, or mortals that you care for them? And yet, you've made them, us, a little lower than God, and crowned them with glory and honor. You've given them dominion over the works of your hands. You've put all things under their feet." Well, this psalmist knew that the stars and the moon weren't under his feet. Not that kind of dominion, but the dominion, I think, talked about here and how we would think of it now is more along the realms of knowledge and understanding. And I think it's the fact that we can ask questions and investigate, even using the tools of science, that to me says we do have a kind of significance. Next slide. So are we significant? Next slide. Perhaps our significance is apparent not from our place or time span in the universe, but from the fact that we exist at all, a product of a universe, maybe a multiverse, that has evolved toward life, and our consequential ability to contemplate good and evil and our place and purpose in the universe. That's all signs of a kind of significance that we hold. Next slide. And I would take this a step farther. As a Christian, I think we've also been given signs of significance from the God responsible for the universe, telling us that the world is actually beloved. We have this precious verse in the New Testament talking about the coming of Jesus, which we believe is God actually incarnate as a Homo sapien in human form on planet Earth. And that God did this because God so loved the world that he gave his one and only Son, that whosoever believes in him shall not perish but have eternal life. There's kind of an invitation there to have a relationship with the God that's responsible for the cosmos, and it's incredible. Next slide. And Jesus himself said, I've come that you might have life and have it to the full. That there's this sense that we need to have this reconciled relationship with the God of the universe, who's actually personal and loves us. This is the gospel. This is the good news. And there's an invitational aspect to this. Next slide. We're not supposed to just be living without purpose. I like this invitation from the prophet Isaiah, who says, come, all you who are thirsty, come to the waters, you who have no money, come buy and eat. Come buy wine and milk without money and without cost. Why do you spend your money on what is not bread and your labor on what does not satisfy? Listen to me and eat what is good, and you will delight in the richest of fare. Give ear and come to me. Listen that you may live. The gospel is that the God responsible for the universe also cares about us and wants us to have a relationship, a reconciled relationship with God. Next slide. Okay, let's talk a little bit more about planets. Here's those exoplanets. Exo means planets outside our solar system. Next slide. We've now found that they're very common, including around the nearest star to our own sun. So the nearest star system is the Alpha Centauri system, but if you look in the lower right there, you see this tiny little planet called Proxima Centauri, and it seems to have a planet in its habitable zone. Next slide. And so this is an artist's imagination of what it would look like on that little Proxima Centauri. Unfortunately, planets are really hard to study in this kind of detail, so we're feverishly trying to build new telescopes that can tell us about the character of other planets and whether there could even be habitability or life on them. Next slide. The Webb telescope and Hubble and others are already taking spectra of atmospheres of exoplanets and telling us what's in those atmospheres. That can give us some clues as to what they're like. Things like carbon dioxide, carbon monoxide, water vapor, all kinds of interesting things. This is a spectrum of a big, large gas giant exoplanet. Next slide. And of course, as our telescopes get better, we're going to be looking more distinctly at their atmospheres to see if they show signs of what we might call biosignatures, so that the evidence that there's living things that are affecting the atmosphere. Well, what would we look for? Well, when we look back at Earth, we can tell there's life on Earth because, next slide, we see evidence of oxygen in the atmosphere. That's continually being replenished by plant life. Next slide. We see liquid water. Well, that doesn't prove there's life, but we know that life needs water. Next slide. We look for reflected light signatures to see if they're consistent with plant life. Next slide. And even we look for certain types of methane emission. Lots of livestock on this planet create detectable methane, so we might find a bovine planet somewhere else. This is all part of what we call astrobiology. Next slide. And we have to rule out other explanations. So this is a quest in the coming years as our telescopes get better, teasing out these spectra of other planets to see if there might be life. We haven't found life beyond Earth yet, but of course we are curious about it. Next slide. People have for a long time, and of course if there's advanced life, we'd like to know if they have a spiritual quality, and C.S. Lewis wrote about imagining this in his science fiction books, this trilogy of science fiction books. Next slide. But one thing that we do know is that planets teach us about Earth. This planet. When we look at other planets, we learn a little bit more about our own planet and life. Next slide. We learn, for one thing, that we're connected to the rest of the universe. We're not just outside observers. You know, the atoms in our bodies were actually forged in these supernova explosions I talked about earlier from other stars. Jill Tarter here in the movie Contact was kind of based on her life. She said we're made of stardust. The iron in our blood in one hand came from a star that blew up 8 billion years ago. The iron in your other hand came from another star. We are the laws of chemistry and physics as they've played out here. And we're now learning that planets are as common as stars. Next slide. And we're observing Earth. So what are we learning as we take our telescopes, but instead of just looking out, we look back down on our planet. And it turns out there's a whole armada of satellites that are looking back at our home planet and teaching us about what's going on in the dynamics of our planet. Next slide. Here's a whole fleet. I know you can't see the individual ones here in the room, but this is just to give you an overview that there are many satellites that have been sent up to look down at Earth. Some of them have already been operating or operated in the past. Some are operating now. Some are planned for the future. Next slide. These, for example, are observing clouds, storms, and tropical cyclones and monitoring them around the planet. Next slide. This suite is looking at sea surface height. How high is the surface of the sea? And compared to 1993, anything you see in this picture that's orange or red is higher than it was in 1993. So you see the little graph there on the right? That's from 1993 up to now. The sea surface is rising because the glaciers are melting, right? So we're watching that with some of these Earth-observing satellites. Next slide, please. These are looking at the color of the ocean, and it can tell us from month to month and year to year about the life that may or may not be filling the oceans. Can you go to the next slide, please? Yeah, and see if you can get that to, click on that, see if you can get it to go. Yeah, so you watch the colors change over the months here, and you can see, first of all, you'll see in the winter the ice at the top goes farther south, and you can see the amount of life seen as chlorophyll in the oceans rising and falling, and this can be monitored over months and years. So these satellites are ways we're learning about how our Earth works, how we're all interconnected, and how the changing of our climate is affecting the Earth as a whole. Next slide. And how deforestation is working. So here's a satellite called Terra, one of the instruments on it, looking down at what used to be a complete rainforest in Brazil. So this region should be all dark green, but all those tan incursions are places that have recently been cleared for farming and livestock. And so we can see what we as humans are doing to our planet by having these global views from up above. Next slide. So how do we respond to this amazing universe and the challenges that we have on our one little planet, Earth? And how should we? I have some ideas. Next slide. First of all, I think we need to take time to just say, wow, how cool. And for some of us, that means giving praise to God. We already heard from Psalm 19, the heavens declare the glory of God. Let's give ourselves permission to feel a sense of awe and humility. Next slide. And then I think we need a sense of responsibility to use the knowledge from science to serve others. We need to care for our own planet and all of its inhabitants as good stewards, meaning other people, other creatures on this planet, using science in ways that act out love. How we use science and technology is a choice we need to make. And I believe those of us in faith communities can encourage people in our faith communities to serve God in scientific fields. Help our young people to think of this as a way of living in ministry to others. Next slide. And then I hope we continue to explore and learn, that we keep curiosity going, keep learning more. That's something that's driven humanity up to the point that we are now and can drive us for greater good in the future. Next slide. Okay. Are you feeling inspired? I hope. So let me kind of draw this toward the conclusions here. Next slide. We have some inspirational things right here in DC. If you go to the National Cathedral, you'll see a space window with a little piece of moon rock there. So there are things you can do in our own churches that can help people to worship God and to think about science as a gift from God, giving us knowledge that can not only help us in practical application, but can also enrich and deepen the ways we worship God. Next slide. We can also worship through service, and I hope my colleague Gladys Kober here, who's in the audience, doesn't mind, but I'm showing a picture that she shared with me. Gladys is a specialist in image processing at NASA, but she has used her own vacation time to in this case, go visit an orphanage where the kids wanted to learn all about space. So using the gifts of knowledge to uplift the spirits of young people is a way of serving. We can use science for service, and she's also created a wonderful textbook, or a couple of them, on the crossroads of science and faith. that can be used in discussion groups for churches, but mainly for Christian schools and home schools, and I urge you to check it out, glimpseofhissplendor.com, and you can talk to Gladys right over here. Next slide. All right, remember I'm also supposed to tell you all about the future of faith. I want to change the question, right? Politicians do that, right? So I'm going to answer a different question. What could be the source of our faith and hope as we look to the future? I have 3 ideas. Next slide. One is, as we look to the ultimate long-term future, the questions of, is the universe just going to expand forever, freeze out, and we'll all be forgotten, and that everything is completely hopeless and meaningless? In Christian faith, we have a different future. It's not told to us in very specific ways, but we have a different future that we have in mind that God has given for the whole world. And it involves the return of Christ. It involves something called a new or renewed heavens and earth. Mysterious little projections like Revelations 21 saying the old order of things has passed away. And so I encourage you to read this book called Surprised by Hope by N.T. Wright, talking about a really biblical-based view of the ultimate Christian view of the future of the universe and our world. And it's a hopeful view, so I hope you'll check that out. Next slide. But I will remind you also that the gospel teaches us that when we turn to God and become reconciled, and through the gift God has given us in Jesus Christ, He creates something new in us. He makes us new. 2 Corinthians 5:17 says this, if anyone is in Christ, the new creation has come. The old has gone, the new is here. So we are part of that new heavens and the new earth already getting started when we receive this new birth that we're given in Christ Jesus. Again, there's an invitation for all of us there. Next slide. And then I think as we're trying to look at the problems around us, there is a hope that our faith gives us. And I like what Katharine Hayhoe, the way she frames it. She's a climate scientist and a Christian. And she's written this book called Saving Us, a climate scientist's case for hope and healing in a divided world. And one of the Bible verses she points out, she says, the faith that God gives us is not one that should make us cower in fear and cynicism. It says right here in Scripture, God has not given us a spirit of fear, but of power and of love and of sound mind. And so that causes Katharine to encourage us and herself to go forward looking at these problems that seem insurmountable, but not to give up, that we actually have power to do something about them. We have information. Science can be used properly if we use our sound minds, and if we use all of this knowledge in a spirit of love to serve and try to reconcile a divided world, we will make a difference. There is hope for the future. We need to combine our minds and the hearts that God can give us. And this is what Jane Goodall taught us. Next slide. Jane Goodall said that only when our clever brain and our human heart work together in harmony can we achieve our true potential. Amen? All right, next slide. I'm going to put for you a bunch of resources that you surely can't read in this room, but these are organizations and books that I particularly think are good at helping us think about the interrelationship of science and faith. And there's a lot of them. I particularly point out the American Scientific Affiliation, which is a network of Christians in science. Science for the Church, which is a relatively new organization, and of course the Dozer program I mentioned to you. Those of you online can take a screenshot of this. Next slide, of course, Wesley Nexus that sponsored this event. And then here's a few more that are focused more specifically on faith communities and doing things about environmental care and our practical hands-on work for climate and the environment. And I urge you also to sign up for Katharine Hayhoe's newsletter. So if you go to katharinehaho.com there, you can sign up for the newsletter where every week she gives you things to be hopeful about, good news, and also things to be troubled about regarding climate and environmental care. And you'll hear tomorrow, if you watch Francis Collins talk, about a book that he's recently written called The Road to Wisdom, which is excellent. Next slide. So let's praise God for the universe, and let's praise God for the gift of science that allows us to explore and understand the wonders of creation and to serve one another in love. Amen? All right, thank you very much.
I want to introduce Dr. Katy Hinman, who is the Program Director of Dialogue on Science, Ethics, and Religion, also known as DOZER, at the American Association of the Advancement of Science.
Well, I always shudder a little bit when I am following Jennifer. I have followed Jennifer as the director of the DOZER program, and there have been many times when I have been called upon to follow her as a speaker, either right away or, when she had been invited to speak to an audience, then I'm later invited, and they're like, oh, this is the person that is now the director of the DOZER program. And I always worry because she has all of these beautiful pictures from NASA, and I studied bat poop, which is not quite so inspiring, at least for, sort of the lay public. There are those of us who find it incredibly inspiring and fascinating, but it is not quite as easy of a sell as the pictures from the Hubble telescope. And I think that's one of the things that actually, thinking about sort of responding to your talk, one of the things that I think is so powerful for us to think about is this question of scale. And looking at these pictures, as you mentioned, looking at these pictures of the universe can inspire this sense of awe and wonder, and it can also inspire a sense of smallness and insignificance if we are only thinking about our lives on that scale. And so I hope that we can also bring the conversation into those smaller scale things. Now, for my work, I was collecting samples of bat poop. I was collecting samples of pollen off of the heads of bats that were visiting flowers. I was collecting tiny little insects off of flowers to see what else might be visiting them, looking at things under the microscope. And it was great to see the visual of the different scales of the different telescopes and honing in on that star cluster from that wide angle, because that's basically, the flip side of that is looking through the microscope, right? And how close can you see at a particular magnification? And then you go closer and closer, and then you get into electron microscopes and all of these other ways of seeing smaller and smaller and smaller things. And it's one of the things that I love, too, when I think about Scripture in the Bible, and I think about sort of those inspiring verses and the life verse, and of course, predictably, we get all of the Psalms, right? And the heavens are telling the glory of God. And my life verse, I think, if I have one, comes from a very different place, which is the book of Job. And one of the things that I love about the book of Job is there's the longest speech that God gives in the Bible is in the book of Job. And basically the entire speech is, you don't know jack about natural history. Do you know when the conies give birth? Do you know where the wild ass gets the water? Do you know this about the Leviathan? Do you know any of these things? Do you know how the clouds make rain? And Job, at the end of this, the verse that I always stick with says, I have uttered what I did not understand, things too wonderful for me that I did not know. And that imagery, things too wonderful for me, because these are clearly too wonderful for us. And also, when rabbits have their babies, is a little too wonderful for us. And yet, we have this drive and this purpose of discovery and of investigating and always wanting to know more at all of these different scales. And I think that that's one of the things that we can learn from all the disciplines of science is that importance of looking at the world in all of these different ways, all of the ways that we can learn about the world. And when you were sharing the quote from, I guess it was Polkinghorne who was talking about theology and science, I mean, there's not just one area of theology, there's not just one area of science. There are, in fact, all of these different ways that we are investigating the world, and they all sort of come into play as we desire to learn more about the world and also learn how we should be living in it. And I think that importance of, I know that when Webb was launched, then I'm sure you got 8 million questions of like, oh, okay, are we done with Hubble now, right? Right, everybody's like, well, we don't need Hubble, we have Webb now, right? But of course, as you pointed out, they are looking at two different spectra of light and two different sets of information that we can get from that, and how much these different instruments work together. And I think that all of them not only inform that sort of concrete or physical understanding of the world, but gaining those different kinds of knowledge can also help us think about the world sort of philosophically differently as well. And I think when we think about how we live in the world, I like thinking about, I really appreciated the different parts of the Earth, I don't remember what they call it, but the satellites that are all looking back at Earth, because we do think of NASA as looking out into space, but all of the things that those satellites can tell us about our planet and the way that they help us see some of the things that we see on the ground in that larger system. One of the sort of connection points, I think, between the work that I was doing and the work that you do is this idea that things are part of systems. I was looking at bats pollinating flowers, and for my dissertation, of course, dissertations always got to focus in on one little bit, right? But of course, these bats are migratory. They travel between southeastern Arizona all the way down through Mexico. They pollinate flowers all along their route. There's also other animals and insects that are visiting these flowers. That's part of a larger ecosystem. And then when you step out away from that, you start looking at things like how climate and other forces are influencing those ecosystems, and then you see how that's part of an entire planetary system, and how a planetary system is part of a solar system, and how it's part of a galaxy. And all of these connections help us to think about the ways that we live in the world and the effects, not just the direct effects of our actions, but those second level effects and the third level effects and the fourth level effects. And so, so those are just some things that I kind of was thinking about as I was hearing you talk. And I was wondering, if you could say a little bit about sort of how you've seen in your work, how that has fit into other areas of inquiry that maybe you didn't anticipate. Is there anything that in your work with star formation and things like that where somebody has said, oh yeah, I used that paper on this completely other exploration, or just with Hubble, the ways that you have that has opened new avenues of inquiry?
Well, I think, let me just answer a little bit more generically. Every time we build a new tool for scientific inquiry, that can be a new telescope or a new type of microscope or a new type of accelerator, or all kinds of, they're usually built to kind of address a specific question, but then you start finding all these things you didn't expect, and then that begs a whole lot of new questions. And that's great, right? So, but part of the problem, we have sometimes selling a new science facility or science instrument or trying to get funding for it sometimes is you have to have something that you're almost guaranteed to learn if you're going to spend all that money on it. But then you also have to be open to new discoveries in ways you can't predict. And I think that's tremendously exciting. I mean, look at, this went all the way back in astronomy to Galileo pointing this telescope. I mean, telescopes were typically used to spy on your neighbors, but Galileo used it to look up and started kind of writing down things he was seeing and suddenly noticing things that he hadn't expected about the moon and about moons of Jupiter and other things. And, so, and that changed the world, right? So, so I think what I've noticed on a more global sense is that science can be pragmatic and technology to address a specific question, but we need to be open to the fact that these tools and techniques that we're using can actually show us things we didn't expect and cause us to ask new types of questions that we didn't even know that we should be asking before. So.
Yeah, that's it reminded me back on Earth, just last week or the week before was the Golden Goose Awards. This is an event that AAAS helps to sponsor, where they highlight sort of maybe silly sounding or obscure research that has then had major positive impacts in the world. And so many of these things are things that people, if they were looking, this of course comes up with funding and things like that. Why on earth would you be funding, this weird research? And then it ends up having these unanticipated impacts farther down the road. And so I think that's one of the wonderful things about it. And it kind of, one of the questions that we received already was, a recent Science Religion newsletter asked, is astrobiology the only faith-based science? And they asked, what do you think?
Is astrobiology the only faith-based science? There's a lot of kind of assumptions underlying that question. Well, I would say astrobiology is driven by an evidence-based curiosity, right? So we don't know if there's life beyond Earth. We've not discovered life beyond Earth. But we're starting to discover more and more things about the universe that make it seem like it's worth looking, and it's worth, and that we can actually find specific ways of answering the question if there's life beyond Earth. So, we've had science fiction for a long, long time, but what's new now is that we're actually detecting scads of planets beyond our own solar system, and our instrumentation has gotten more sophisticated that we can start actually studying these other stellar systems. So it's not just science fiction or wishful thinking or groundless faith. It's actually grounded in new knowledge, which now gives us the ability to ask questions that are scientific, that we can measure, And so we need to understand what it is we need to measure to know if there's even simple life beyond Earth. So that's what astrobiology is about. It's a real science based on real observations, with a hope that we can actually learn more about the extremes of life on planet Earth and how that might relate to the possibility of life elsewhere.
Well, and I think that, I would say all science is faith-based science because it is based on the faith that we can figure things out, that the universe is figure-outable, which we don't necessarily have a particular reason to accept that that's the case. I will also point out that faith is not unbased. It's not wishful thinking. And of course, we have at least a somewhat Methodist crowd here. So shout out to the Wesleyan quadrilateral, right? Scripture, tradition, experience, and reason as the things that are informing our belief. That actually brings up another question that the person shares. Some years ago, material was discovered on Earth ejected from Mars that suggested life on Mars. And my lab director asked me if this would dismantle my religious faith. It says, the Mars excitement faded, but our understanding of exoplanets makes it likely that life exists somewhere else. What do you see as the theological significance of life elsewhere?
Oh, what a great question. So there's a theologian named Ted Peters who did a study where he did a survey of people from different faith traditions, including people with no faith. So people from various religious traditions and people who had no faith, and asked them, if we found life on some other planet, life beyond Earth, would it shake your faith? And by and large, 99% of everybody in every faith tradition said, they thought about it, whether they were Muslims or Catholics or Protestants or evangelicals or Hindus or even people who said they were atheists or agnostics. Everybody, for the most part, thought about it a little bit and said, no, my faith tradition is big enough that we can handle. We might have to make some tiny adjustments, but we can handle the idea that God, if we believe in God, that God is responsible for life elsewhere, and we can rejoice in that. But then he asked them a second question: what about these other faith traditions? What do you think that people in some other faith tradition will respond? How they will respond? And almost everybody in these various faith traditions would say, well, people in this other faith tradition, their faith will fall apart, And the people who were devout theists or believed in God said, well, this will prove to the non-theists that God is real, because look, you could see all this life everywhere. It just shouts that God exists. And the atheists or the non-theists said, oh, all those religious people, they're going to lose their faith because it's just going to shake everything they've based their faith on. So for some reason, this is a sociological issue. For some reason, humanity thinks that when we discover life elsewhere, it's going to completely expunge everything that we currently have believed throughout human history, and we basically have to start over. Except not in my own tradition, right? So this is a question for sociologists and historians to look into. So, no, I actually do not think that finding life beyond Earth will shake Christian faith. It will enrich it, because the God of the Bible is responsible for everything that there is. And the Bible doesn't say anything about life beyond Earth. That was probably beyond the scope of the original audiences, but it was not beyond the scope of the original writers of Scripture to know that whatever is there, God is responsible for. And God declared that creation is good. So I think we can keep that in mind and therefore have a sense of excitement as we look for the possibility that the same God who filled Earth with diverse, interesting life may have filled the universe with it.
I think that's a good segue to this question. Given what NASA continues to tell us about the age and fate of the universe, do we need to fashion a new current creation story that coheres with the metaphorical truth of Genesis 1?
Oh, wow.
These are great questions.
Let me say this. I'm not a theologian, but I think we can understand the message of Genesis is extremely rich and extremely powerful. It was never written to be a science text. You know, science was only invented a few centuries ago, so the original audiences would never have interpreted it as a minute-by-minute historical account of how the universe and life came to be. Even St. Augustine said that we weren't supposed to read Genesis that way. But it is telling us something even more profound, that the universe is not a random accident. You know, that the universe is created by God, for God, and it's ordered, and God created spaces, you know, the lights in the sky and the firmament and then the land and separated lands from waters and filled these places on earth with living creatures. So there's places and there's functionality and there's life in these places, and God declared all of this good. And some of those verses say that God brought forth, you know, from the ground, living creatures. So there is a kind of sense that the processes of nature are part of God's creative act. We should never read Genesis to be something less than it was meant. It was not meant to be a science guidebook. It was meant to tell us something more profound, that there's purpose and that God is behind the universe. God declares it good, and God wants a relationship with his creatures.
Well, and I want to piggyback on that, because I don't want us to forget the story of Genesis 2, because I think one of the powerful things about this, and I think one of the challenges that you kind of alluded to in your line of work, is that, okay, well then where's my personal role in this? You know, if this is this big cosmic story, what difference do I make? What difference can I make? And the Genesis 2 story brings that very personal, you know, people are in the garden because they're part of that creative process, and the individual actions of the people in the garden are what helps the garden to grow. And I think one of the challenges that we sometimes run into is, especially in the face of the ecological catastrophe that we are facing, is this idea of like, what difference could I make? What does it matter if I do? You know, is it one person going to make? And I think that balance is really powerful. So, in your own life, is there an example of sort of, what's the example of these are two related questions. What is an example in your life of the closest connection between your faith and science? And what surprised you most during your career, and did it change your faith?
Oh, wow. I think I mentioned at the beginning of my talk that I love nature, so it was quite natural for me to, having grown up in a Christian family, so I didn't have some dramatic conversion experience. It was more that as I grew up, I realized that this was not just an intellectual pursuit, that God wanted me to have a personal commitment to Jesus Christ. And so as a scientist, studying the natural world just came naturally to me because I love the natural world. So just science is a way of learning more about the details, and I love space, and I think it's really cool. I think what surprised me is that most of the ways that my faith intertwines with my life as a scientist is not in these romantic thoughts of, contemplating the universe and its purpose, such as I got to talk about tonight. Mainly the only times I get to really, bathe in this kind of thought, just when I'm giving these wonderful talks. Most of the time, we're dealing with what all of us deal with, which is whatever your job is, the deadlines, the emails, the difficult interpersonal relationships, the stresses, the disappointments. And in a scientific environment, one way of serving God with God's help is to love your colleagues and to try to help build research teams that, first of all, you're choosing topics that are uplifting to study, and you're making choices about how you do the research that is the most positive, and that you are doing things that involve students or people that might otherwise have a hard time getting a foot into the door, helping people get a chance to be a part of the scientific enterprise, being compassionate, being, caring about one's colleagues, and trying to be a helpful voice in situations of stress or disagreement. So those are the non-romantic things that I think are part of the life of, all of us in our various walks of life, but certainly in a scientific setting. And research can be disappointing, right? And it can be mundane. And I think, we always see kind of the glamorous results of science presented because that's what we talk about. But there's so many months and years in a scientist's life when there's no tangible results, or it's disappointing, or it is good results, but it's just kind of not very flashy, So these are the kinds of things that are hard, and spirits can lag. And so I think one way that as a person of faith, I've learned that God provides encouragement to me in the mundane things that I ask God for help for, and the stressful deadlines and all that, and also to be mindful of the stresses my colleagues are under as well.
I believe I'm being signaled that we are at wrapping up time. So, quick question, is your comet coming back?
So, Comet Wiseman-Skiff, S-K-I-F-F, is named after myself and astronomer Brian Skiff from the Lowell Observatory in Arizona. And this was a wonderful, unexpected discovery when I was a senior in college out there for a field camp for students, learning how astronomers actually use telescopes. And we found an object that had not previously been charted in the sky, and it turned out to be an undiscovered comet. The good news is that it comes back every 6.5 years. So it's not like Halley's where you have to wait 70 years or something like that. 6.5 years, Comet Wiseman-Skiff comes back around. The bad news is that Comet Wiseman-Skiff is really very faint. So you really need to know what you're doing. But if you go online and Google Comet Wiseman-Skiff, you'll see its lovely little picture. Don't expect a dramatic tale or anything. And I think it's due back in probably 2 or 3 years, but I'd have to look myself. So it's coming back. Yeah. Excellent. Yeah.
Well, I want to thank everybody for their questions. I'm sorry for the questions we didn't get a chance to get to. This has been very elucidating for me to see all the different stars and the depths of it, and you're just so totally over my head, it's not funny. But this has been really very informative. I want to thank everyone who's online for hanging in there. I know that this will be, ultimately, a link will be posted on the Wesley Nexus website. You can also interact through the Wesley Nexus Facebook page, and we have a way to talk back and forth, and the comments are screened, but anyway, eventually there's a way to get through that way. Thank you all for coming, and pray for everyone for a safe drive home, and for those at home, a nice good night. Thank you so much.
Thank you.